Welcome back to another deep dive, and a very warm welcome to you, the learner. We are so glad you're joining us today.
Yeah, thanks for tuning in. I'm really excited about this one.
Because today our mission is to take a single, seemingly basic Wikipedia article about a flower, specifically the Iris virginica, and prove to you how a single source can connect the mud of a North American swamp to, well, the literal foundations of modern mathematics.
It sounds like a stretch, I know, but the trajectory from a wet ditch to complex statistical models is it's incredible.
Okay, let's unpack this, because the premise here is that you might walk past this plant in a wet ditch somewhere without a second glance, right?
Oh, absolutely.
But if you do that, you'd be ignoring a medicinal marvel and a true scientific legend.
Yeah, it's known by a few names: the Virginia blue flag, Virginia iris, great blue flag, or southern blue flag.
Right. Which usually means people have a long history with it. But before we can really understand its legacy, we have to look at the plant itself, right? Like how it survives and what it actually looks like out in the wild.
Yeah, the physical structure is key. It's a perennial, and it grows about 2 to 3 feet tall. So that's roughly 0.6 to 0.9 meters.
Okay. Pretty tall for a swamp flower.
Yeah, and it has these distinct bluish-green, glabrous basal leaves. They're sword-shaped, and they can get up to 3 feet long and about an inch across at the base.
Wait, what does glabrous mean?
Oh, glabrous just means smooth. No hairs or bristles, just a completely smooth surface.
Got it. You know, when I was reading the source, I kept picturing the anatomy of this flower as like a miniature royal pavilion standing right in the middle of a swamp.
Oh, I like that analogy.
Well, yeah, because you have these smooth sword-shaped leaves, right? And they act like the guards around the base.
Right, standing at attention.
Exactly. And then rising up from those guards are these unbranched or sparingly branched stalks. And they feature 1 or 2 flowers emerging from the axil on these 1 to 5 inch pedicels.
Which is basically the little stem attaching the flower to the main stalk.
Right, right. And then from May to July, the pavilion, it opens, you get these blue to blue-violet flowers that are about 1 to 5 inches across.
It's a really striking visual, especially the petals and sepals.
Yes. The anatomy is so specific. You have 3 upright petals, which botanists literally call standards. So, continuing my pavilion analogy, those are the kingdom's flags flying high.
It fits perfectly.
And then below those, you have 3 drooping sepals, which are called falls. And they have these distinct white marks and a bit of yellow near the throat. They look exactly like grand, rolled-out carpets.
What's fascinating here is how that highly specific architecture allows the plant to adapt geographically. I mean, it is incredibly resilient.
Yeah, the range is massive.
It really is. It's found in wet areas across the U.S., stretching from Nebraska all the way over to New York.
Wow.
And from Florida and Texas right up to the Canadian border. It even grows in Ontario and Quebec.
That's such a crazy temperature difference from a swamp in Florida to a freezing marsh in Quebec.
Exactly. But the unifying factor isn't temperature, it's water. It thrives in marshes, wet meadows, swamps, sloughs, sinkhole ponds, and ditches.
Sinkhole ponds. Just the phrase sinkhole pond sounds like a harsh place to live.
Oh, it is. But despite that, its conservation status is listed as least concern or secure. It is completely dialed into its environment.
Which naturally leads us to the people who lived in those environments. Because the Iris virginica grows in these intense waterlogged areas across the continent, it inevitably crossed paths with the indigenous peoples living there.
Right, people who were paying very close attention to their ecosystem.
Exactly. They discovered its hidden internal properties. It wasn't just a pretty pavilion, it was a swamp pharmacy.
Yeah, the source outlines some very specific traditional medicine applications, mainly using the root.
And they weren't just using it for one thing. The Cherokee traditional medicine used the root in several ways. For instance, they pounded it into a paste to use as a skin salve.
Which makes sense for topical issues.
Right, but then they also made an infusion from it to treat liver ailments and a decoction to treat what the source calls yellowish urine.
And, we should clarify the difference there. An infusion is like steeping tea, drawing out the delicate compounds. But a decoction is boiling the tough root material to extract completely different active chemicals.
It shows such a deep understanding of the plant. But here's where it gets really interesting, and I actually want to push back on this a little bit.
Oh, okay, let's hear it.
So the source mentions seminal traditional medicine, and it says it may be used to treat shock following alligator bite.
Yes.
I mean, come on. It's hard to imagine that a delicate-looking blue flower has the chemical punch to deal with something as traumatic as an alligator attack. Are we are we underestimating swamp plants here, or is this more of a folk remedy?
I get why you'd think that, but we are absolutely underestimating swamp plants.
Really?
Yeah. Think about the environment. A sinkhole pond is basically a soup of aggressive microbes and bacteria. For a fleshy root to survive, submerged in that mud without rotting, it has to produce incredibly potent chemical defenses.
Oh, so it's like a chemical weapons factory just to stay alive.
Precisely. Indigenous medical practitioners had an incredibly nuanced understanding of botany. They knew that a root capable of fighting off swamp rot contained highly active compounds.
Okay, that makes sense.
Right. And when someone is bitten by an alligator, it's not just a wound. The body goes into systemic shock, blood pressure drops, the nervous system panics.
Physiological trauma.
Exactly. They were turning this common swamp root into targeted decoctions and salves to handle both the external trauma and the massive internal shock to the nervous system.
Wow, so they were isolating active compounds to stabilize a patient. That is real pharmacology.
It really is. And that careful observation of the plant's traits didn't stop with traditional medicine.
Right, because we have to transition into the 20th century now. Observing the exact physical traits of the Iris virginica led to a breakthrough in a completely different field.
And this is the jump that always blows my mind.
Yeah.
We go from indigenous medicine to mathematics and data analysis.
It's wild. So the source notes that the plant was identified as a separate species by a botanist named Edgar Anderson.
Yes, Anderson is a key player here.
And he didn't just casually identify it, he meticulously measured it. The Iris virginica is one of 3 iris species in what became known as Anderson's famous iris flower dataset.
He collected 50 samples of each species, measuring the exact length and width of those sepals and petals we talked about earlier.
It falls in the standards.
Exactly. He created this incredibly precise numerical record of the flower's architecture.
Okay, but then the source introduces someone who isn't a botanist at all, Ronald Fisher.
Right.
In 1936, Fisher published a landmark paper called The Use of Multiple Measurements in Taxonomic Problems. And he used Anderson's dataset as an example of something called linear discriminant analysis.
Yes. Which sounds intimidating, but it's a foundational statistical concept.
So what does this all mean for the listener? I mean, why is a statistician in 1936 measuring the falls and standards of a swamp flower to do math? What's the point?
If we connect this to the bigger picture, Fisher was trying to solve a massive problem in science. How do you mathematically categorize things when the data overlaps?
Like, if 2 plant species look really similar.
Exactly. A large Iris virginica might look like a small version of another species. If you only look at one measurement, like petal length, you can't draw a clear line between them.
Because there's a gray area.
Right. Fisher needed a reliable, standardized set of multiple physical measurements to prove a new mathematical model. He wanted to use multiple data points at the same time to mathematically draw a definitive boundary between species.
Oh, I see. So Anderson's precise botanical measurements of the Iris virginica provided the perfect raw data for this.
It was the exact data he needed. Fisher took those 4 measurements, sepal length, sepal width, petal length, and petal width, and showed how to use them simultaneously to perform linear discriminant analysis.
That is just... It's staggering when you really step back and look at it.
It really is.
I mean, to wrap up this journey for you, the listener, we started out looking at a wet ditch, right?
Yeah.
With this bluish-green plant and its smooth sword-like leaves.
The miniature royal pavilion.
Yes. And then we traced it to a Cherokee skin salve and a seminal alligator bite remedy. Just incredible botanical mastery.
And from there, to Edgar Anderson taking out a ruler to record its botanical measurements.
Which handed Ronald Fisher the exact numbers he needed for his 1936 statistical milestone. It proves that knowledge is utterly interconnected. A swamp weed is tied to the math that helps categorize our world today.
Absolutely. And, I want to leave the listener with a final thought to mull over.
Oh, please do.
Ronald Fisher used the measurements of this specific flower to solve taxonomic problems, literally figuring out how to categorize the chaotic natural world using multiple data points.
Right.
So I would ask you, the listener, to just look at the plants outside your window today. Look at the weeds in a wet ditch or the flowers in a marsh.
Yeah.
What other hidden mathematical codes or undiscovered scientific breakthroughs are just sitting there in the soil waiting for someone to take out a ruler and start measuring?
That is such a great thought to end on. Because it's all out there, just waiting for us to notice it. Well, thank you so much for joining us on this deep dive.
Thanks for having me.
We'll see you next time.